Welcome to your next training videos. These ones are all about graphing linear equations. Here are the topics that we will cover. First, the three different types of graphing methods. 2, slope and how to interpret it, how to find it. And 3, writing linear equations in the 3 different forms. Let's go ahead and start with how to graph 3 different methods. Up until now, a lot of your students will have just been solving equations that have one variable. You find the value of x and you're done. When they come across something like this that has 2 variables, no other information, that is a new concept. Right? How can we solve it if there's 2 variables? And so you want to really help them to understand that there can be a lot of different options. For example, if we say x equals 6, the only option for y is that y has to equal 3, right? 6 plus 3 equals 9. But those aren't the only options. If x equals 10, y equals -1. If x equals 5, y equals 4. So there's lots of different possibilities. If we look at those on a graph, we go 6 on the x-axis up 3, and then 10 on the x-axis down 1, and 5 up to 4. You'll notice that these points line up in a line. I always tell my students, if you miss a dot, you just make it bigger. There we go. Perfect. So a graph is the visual representation of all those infinite solutions, which is why we put the arrows at the end to show that it goes on forever in that plane. So a graph is a visual representation of solutions. Every single point on that line, if I plug in the x where the x goes and the y where the y goes, I get 9 when I add them together. This idea of picking one variable and then figuring out what to go with it, right? Pick the x equals 5, y has to be 4. That process is our first method. I call it pick, plug, plot. Well, I'm missing a comma. There you go. Fix it. You'll also hear it called pick and stick, plug and plot, choose and cruise. You could hear it called that. But really what you do is you're going to pick values for either variable. Usually students pick values for x because they're just used to that. And then plug it in and solve for the other variable, which in this case is probably going to be y, and then that's going to be some points to put on your graph. So let's go ahead and do that for this equation. Give me some room. So I'm going to pick some values for x. This is where you'll see a lot of students use the t-chart. I'm just going to pick -1, 0, and 1. Let's plug those in. So 2 times -1, that's -2. Go ahead and add that to the other side. Plus 2, get 3. So that's going to be y equals -3. That's going to be on my graph. -1, -3. All right, let's plug in 0, my favorite number to plug in. Get -y equals 1, so y equals -1. And then my next one, 2 times 1 minus y equals 1. Plug that in, subtract 2. So I'm going to get y equals 1. Alright, so my points are -1, -3, boom, 0, -1, and 1, 1. All on this line here. Connect the dots. There you go. That's pick, plug, plot. The nice thing about this method is that you can use it for anything you want to function. So if you're helping somebody in calculus or college algebra and they're trying to graph a logarithm, you can plug in numbers, figure out what the other variable is, and get an idea of what the graph looks like. This will work for anything, not just linear functions. Which isn't true, sadly, of our other 2 methods, but let's look at them anyway. Next is all about intercepts. The word intercept means to obstruct from a continued path. So, for example, in American football, one team throws a football, the other team catches it. That is called an interception. On a graph, here's my little graph. Look. Here's my football. It's been thrown by one team. The y team catches it here. The x has no football at that point. And then they throw it poorly, and here the x team catches it at the intercept. So when you hear intercept, it means where it touches an axis. An intercept is where the graph touches or intercepts an axis. crosses its path. Alright, so let's have a, if we were to find them, because obviously on a graph, right there, it's where it touches the axis. Boom. But if we don't know where it touches an axis, we can figure that out. And it's very useful for graphing. So say if I know that it's like right here and right here, boom, 2 points done. Let's talk about how to find it. Okay. At each of those points at the y-intercept, x is 0. That's always true. And the x-intercept, y is 0. Right? They have 0 footballs at that point. And so we're going to use zeros to find the intercepts. Let's do it with this example to clear off some of these footballs. We can graph. Right, 4x plus 3y equals 24. First, plug in 0 for x. I told you I love plugging in 0. It just makes that part of the equation go away. 3y equals 24 divided by y. Oops, not by y, by 3. Oops, I'm thinking now 3. So y equals 8. If I put, okay, so that is my y-intercept, 0, 8. All right, that's the y-intercept. And then my x-intercept, I'm going to do the opposite. Plug in 0 for the other one. That part goes away. Divide by 4. X equals 6. So 6, 0 is called the x-intercept. All right, and put those on my graph. 0, 8 is way up here. 6 zeros are way down here. Third step, plot the points and then connect. We'll see how this goes. Oh, that's pretty good. That's pretty good. Alright. That is the intercept method. Obviously, it works for lines really well. If we have more complicated functions, say if we have a cubic function, we'd have to know a little bit more about it, right, than just the intercepts. Maybe it's like this. We don't know that intercept. We don't know also how far down it goes. We have to learn more things about it. But this is really useful for linear functions. All right, third method deals with slope, which we are going to talk about in our next video. So if we haven't got to it yet, that's okay. But for now, we're just going to use this definition. That's really helpful for this next method. Slope is the rate of vertical change, so the change in y, compared to horizontal change or the change in x. That's going to be really useful. If an equation for a line is written in a specific way, you can just see the slope and the y-intercept just by looking at it. It's called slope-intercept form. You're very familiar with this, I'm sure. I feel like you couldn't be a math tutor if you hadn't heard of that before. So you've got this covered. But we've got the slope here and the y-intercept. That's always true. So if we know the intercept, that's 1 point, and we can use the slope to find another point. Here's the process. So if we look at -1 on the y-axis, right, our y-intercept, we just learned the word intercept in the last slide. The vertical change is +2 because it's on the top of our rate of our function, or sorry, our fraction. So this is +2, that means it's going to go up 2 from that point, okay? Up 2, I'm just going to draw myself a little ladder, up 2. And then our horizontal change down here is 3. Oops, not down. It's going to, because it's positive, it's going to go 3 to the right. So from that point, now I'm going to go 3 to the right. And that should be another point on the line. If you think about it, we have 0, -1 as 1 point, and then the y value goes up 2, and the x value goes up 3, well, right 3. So 3, 1, which is the point we just found. Now we have 2 points. You only need 2 points to graph a line, so we're done. There it is. Here's our process for this one. Y equals mx plus b. Right, that's just what I called this method using slope. Plot the y-intercept at 0b, whatever b is. Ours was -1. Use the slope to find another point. Which we did. We went up 2 and to the right 3 and connect those points. Let's try one more using our process. Make some room on my graph. Alright, sometimes with slope-intercept form, you'll have to solve for y, because remember, this is only true when y is by itself on one side. We have to get it alone. So let's do that with this problem. We're going to subtract 2x We don't have to divide by anything because y is already by itself. So we have negative 2x plus 5. So our y-intercept is 0, 5, up 5 from 0. And then our slope, even though it doesn't have a fraction, we can write 1, negative 2 over 1. That means it's going to go down 2 and right 1 because that 1 is positive. Down 2, right 1. Of course, we could do this as many times as we want. We only need to do it twice. Well, we only need to have 2 points. Also, you could think about it as 2 over negative 1, right? That's still negative 2, which would be 2 up and 1 left, which if we go up 2 and left 1, it still is on the same line. So you can interpret it either way. Just don't put the negative on both the 2 and the 1. That would make it positive. Go ahead and do the last step. Connect your dots. Let's see how we do on this line. Pretty good. More dots makes it easier. Here we go. Alright, those are the 3 methods of graphing. A lot of students will prefer this last one, but make sure that they know the other ones because it is useful to find intercepts, and they can use pick, plug, plot for anything that they want to graph in the future, as well as lines. Go ahead and watch the next video all about slope.